Okay, this is the problem set 1.2, and when we're looking at some of these problems here, such as 3 through 14, they're just asking you to find out what the angles are. Remember, you're going to have to find x, but then you're going to plug x back in to the original problem in order to find out what the angle is. So for example, number 14, we're looking for what this angle is and what this angle is. We know that they're equal, so we're going to write 15x minus 54, and we're going to say that that's equal to 10x plus 11. We're going to solve for x, and then whatever x is, we're going to plug in here to find out what each of those angles are. Now you know they're going to be equal because of alternate exterior angles. Alright, so 15 to 20, it says the measures of two angles of a triangle are given. So some of them are decimals, like 18 is 136 degrees 50 minutes. The other one's 41 degrees 38 minutes. In 20, it says one is 29.6 and the other one is 49.7. We just have to subtract those from 180 degrees to get the third angle, so it's not too bad. Then there's some questions, 21 and 22. 23 through 24 just uses the drawings there. 25 through 36. If you look at those, they want you to classify the triangle. That's all you're doing. You're saying whether it's an acute, right, obtuse, and then once you determine that, you're going to tell me whether they're equilateral, isosceles, or scalene. So if you look at number 26, none of the lines are the same length, so it's going to be scalene. Also, one of the angles is greater than 90, so therefore it's an acute triangle that is also scalene. So you're looking at the angles to determine whether it's acute, right, or obtuse. Then you're looking at the line segments to determine whether it's equilateral, isosceles, or scalene. All right, so then that just takes you into some of the story problems, and 41 through, is it 48? No, all the way through 50 is showing you similar triangles, and you use that whole proportion where, like in number 42, name the corresponding angles and the corresponding sides. So it's pretty easy there because 42, one of the lines is AB, so what's the corresponding one? PQ. Okay, so they're pretty easy to see. 43 and 44 are a little bit trickier because of the way they're turned. 45 through 50, you're finding the unknown angles in each pair of similar triangles. So what you're going to do with that is you're going to look and say, okay, well, 46, angle B is 46, angle M is what I'm looking for, but notice those two lines and those angles, they're sharing those. So that means that the angle B and angle M are the same. Well, you know, angle B is 46, so therefore angle M is, 46. Same with C and P. So it's just getting you used to being able to recognize the different angles. So 51 to 56 is what I was thinking the other ones were about. Find the unknown side lengths labeled with a variable in each pair of similar triangles. So 51, you're finding both A and B. So let's go ahead and get rid of my stuff here and look at that. So 51. Let's say we're going to find B first. So we're going to write that as 25 over B equals, and then what? Well, it's 25, so it's the hypotenuse. We're going to pick the hypotenuse here. 10 over, this is the short side, this is the short side, 6, cross multiply. So make sure you're writing the similar lengths down. So if this is not similar lengths, corresponding lengths down. So if this hypotenuse is 25, you're going to pick this hypotenuse. You're not going to pick 8 to correspond with because it's obviously not the hypotenuse. So make sure you pick the right ones. And as you're looking at the story problem, starting with number 57, they should not give you too much trouble because they're very similar to the one that we just did with the flagpole a little bit ago. So you should be able to figure those out. Now let's look at 63 to 66. It says we've got two similar triangles. Well, let's look at 63. We have, we have this and this and this, and then we have a line here that's 50. We have an x, we have a 120 that's to here, and then this is 100. Okay, and they said that they're similar. This triangle is similar to this triangle. Okay, so we have two triangles. So let's look at what we've got here. In fact, let's break them up into two triangles. Let's break into the little one, and let's look at the big one. This is x, this is 220, because when we add the lengths of these together. Now I can find x, because I can say 50 is to, oops, let's do it the other way. 50 is to 100 as x is to 220. Cross multiply, solve for x, and I'm done. Okay, so that is the problem set for lesson 1.2.